Now we will start the topic of rectilinear motion. Rectilinear motion can be directly written as motion of a body along a straight line. Body moves along a straight line either forward or backward, in either direction when body moves along a straight line. This motion we simply call as rectilinear motion. And, in case of rectilinear motion, body moves along only one dimension of a coordinate system, we can simply write it motion in one dimension. So motion along a straight line can be either termed as a rectilinear motion or motion in one dimension. Before proceeding further in motion in one dimension or motion in 1D, you must understand one thing very carefully, that is reference frame. The concept of reference frame itself is very important to understand. Almost in all problems of mechanics, which we'll study further, reference frame is simply, you can simply say it is region or zone from where observations are taken. For motion parameters of a body. When we talk about observations for motion parameters of a body when a body moves with the motion of a body, the parameters which associated are simply, we can say, displacement, velocity, acceleration, time, parameters associated with motion of a body. The region from where all these observations are taken we defined as a reference frame. Reference frame. It can be at rest or maybe in motion, maybe moving. Like for example, if you are standing on ground and you are looking onto body which is moving at a speed of 10 meters per second. Then in your reference frame or with respect to ground, we can say body moving at 10 meters per second. But the same body when observed by a boy who is standing on a skateboard which is moving at some other velocity, say 10 meters per second. And we can say this boy, who is moving at a speed 10 meters per second, he will feel that this body, X body, is at rest. Both of these are moving at a speed 10 meters per second, so we can say this boy will not observe any motion in this body. So in the reference frame of observer, A, this body is moving at 10 meters per second, and the reference frame of observer B, this body at rest. So reference frame we can simply define as a region or zone from where observations are taken for motion parameters of a body, and either of the parameters can be recorded when a moving body is observed from a given reference frame. If we take of another example, to understand the concept of reference frame, say we are having a car which is moving at speed of 3 meters per second, and a boy who is standing at rest on ground. So we can say the reference frame of this observer is ground. Here we can say reference frame is ground, because he is measuring the motion parameters of this car from ground. Now if we consider another observer was moving on a trolley like this. Say this is observer A, and this observer B, who is on a trolley which is moving at a speed of 1 meters per second. So here we can simply call reference frame is trolley. Now from this trolley, this observer B measuring the motion of car. Here we can say speed of car with respect to ground frame is. Simply we can call velocity of car as measured from ground frame is 3 meters per second. And here we measured speed of car with respect to reference frame of trolley. In this situation velocity of car as measured by the observer B can be written as car is moving at 3 meter per second. 3 meter per second, and this trolley is moving at 1 meter per second. In 1 second it will travel 1 meter in 1 second and it will travel distance 3 meter. So as seen by this observer, it has progressed a distance of 2 meter in 1 second. So we can say its velocity is 2 meters per second. So we can see, with respect to various frame of observation, the motion parameters, like here we observing velocity of this car. The motion parameters measured at different. So we can simply state a reference frame is a coordinate system with a clock. And all motion parameters are related to time. For measurement of time. A coordinate system with a clock for measurement of time. It may be at rest, on ground, or may be attached to a moving body or observer. It is a basic definition for a reference frame. We just go through all the things once again because reference frame itself is a very important concept, because all problems which we are going to face in the chapter motion in one-dimension motion and two-dimension motion or any other topics of mechanics, these are all related to reference frame. Now we will study about various kind of motion parameters associated with motion of a body. The very first is distance and displacement. I hope in your earlier classes, you have covered basic difference between distance and displacement in motion of a body. Say body starts from point A, and along with this path body goes to point B. This is the path along the body is moving. So the length of this path we simply call as distance. We just talk about distance covered. This can be written as path length. If we just talk about the term displacement, it is the shortest distance between point A and point B. We call a displacement vector because displacement is a vector quantity. When we talk about displacement, it is simply a straight line length, A to B. AB vector is a displacement vector which is associated with body. Now say, for one-dimensional motion, when we talk in case of rectilinear motion, when a body moves along a straight line, say it is possible that from point O a body starts. It moves in forward direction. At some point A, it will come to rest, then it will return back on the same line and reaches at point B. So here we can simply state when we talk about distance, covered by the body. So this distance we can write as OAB. It goes from O to A, then A to B. The total distance will be OAB. And when we talk about its displacement can be written as OB vector. It is directly from starting point to the end point, this the vector OB which we call as displacement vector. Now the second point, if we will talk about the motion parameters, speed and velocity. Speed and velocity are exactly related to the phenomena which we have studied in distance and displacement. When we will talk about speed, it is scalar quantity, and it is measured by calculating distance traveled by the body in given time duration. And velocity is a vector quantity which gives on which is measured by calculating the displacement covered by the body in a given duration. So if we talk just about speed, you can simply call it is rate of change of position of body, and here we measure only the magnitude. But when we talk about velocity, velocity is also given as rate of change of position. But in case of velocity we must mention the magnitude as well as direction. Without direction the velocity will be incomplete information. It just be the magnitude of velocity, which can be written as speed and velocity. These can be defined in various ways. Let's see that in the detail. Let us discuss the concept of average speed and average velocity. When a particle moves, average speed in a given motion can be written as total distance traveled divided by time taken. Similarly, we can also define average velocity. For a particle motion, average velocity can be written as total displacement divided by time taken. When a particle is moving in a single direction, then there won't be any difference between average speed and average velocity. For example, a particle starts from point A, goes to point B, situated at a distance L, and say at time t1 it was at position A, and at time t2 it was at position B. Average speed in going from A to B can be simply written as L by t2 minus t1. And same will be the average velocity. There won't be any difference in average velocity and average speed. But see, in one-dimensional motion situation is like this, that a particle starts from point A, goes to point B, situated at a distance L1, and it comes back to point C by traveling reverse distance, L2. And say at time t1 it was at position A, and at time t2 it was at position C. In this situation we talk about average speed. Average speed we write as L1 plus L2 by t2 minus t1. Because on moving from point A to point C, total distance covered will be L1 plus L2 and time taken is t2 minus t1, and here we calculate the average velocity. Can be written as displacement upon time, so here displacement will be L1 minus L2, and time remaining same, that is t2 minus t1. That's the basic difference between average speed and average velocity. In average velocity we must also mention the direction in which it is moving. Here it is moving from A to C, this direction towards east. So we can simply state in this direction average velocity, which is given in vector form. And we can write delta L vector, which is from A to C divided by delta t, or we must write their magnitude and the direction, which is towards east or along positive x-axis.